10.1 notes, law of sines, page 6. So example 6, we're still using law of sines to solve the triangle. So I am going to draw yet again another one of my super fabulous triangles. I'm going to label what we've got, capital A. So A, B, and C, and the sides opposite A, B, and C. Angle A is 42 degrees. Side A is 22 inches. And side B is 12 inches. Okay, so I'm going to start by finding angle B again. The sine of B over 12 is going to be equal to the sine of 42 over 22. So we get the sine of B equals 12 times the sine of 42. Multiply both sides by 12 to get that out of the denominator, divided by 22. And we crank that out, we get approximately 0.36498, and there's a 0 after that, so I'm not going to write any more. So the inverse sine of this 0.36498 is B, and we get 21.41 degrees. Okay, so first angle found. First angle found is our angle B, 21.41, is less than the angle that was given. So we're only looking for one triangle. Okay. So we know now that the measure of angle B, we just found that is 21.41 degrees. So we can find the measure of angle C. We've got to do that before we can find the side. And again, all three angles add to 180. So we're going to take 180 and subtract off the measure of angle B and the measure of angle A. And we get an angle C that's 116.59 degrees. So there's measure of angle B. There's our measure of angle C. And now I need to find the length of side C. And so we're going to use law of sines with our C's and our A's, because our A's are what we had given in the problem. I get C is going to equal 22 times the sine of 116.59, all divided by the sine of 42. And we get C is approximately 29.40 inches. Now, here's one other thing, and I haven't mentioned this in a while, but it's always nice to be able to double check. Our smallest angle, which is B at 21.41 degrees, is opposite our shortest side at 12 inches. Our largest angle, C, at 116.59 degrees, is opposite our longest side at 29.4 inches. And then angle A and side angle fall in the middle. So the shortest side is always opposite the smallest angle, which makes sense as we work with law of sines and we're dealing with the proportions. So that's it for those examples. If you need another example, be sure to reach out and we can go through another 1 or 2 or 4 of these, whatever you need. Let's go on to part 2. We want to find the area of an oblique triangle using the sine function. I am not going to bore you with the derivation of this like I did with the law of sines. Just know the area of any oblique triangle is 1/2 times the product of two sides and the angle between those two sides. So notice up here, this is written all three ways. We've got 1/2 side B times side C times the sine of angle A, or 1/2 the length of side A times the length of side C times the sine of angle B, or 1/2 the length of side A times the length of side B times the sine of angle gamma. Okay, so let's take a look at example 7. Find the area of a triangle given that beta is 42 degrees, side A is 7.2 feet, side C is 3.4 feet. We want to round that area to the nearest tenth. You guys, we can draw this picture again. Notice something though in the formula. We've got one A or alpha, one B or beta, one C or gamma. So here in our problem statement, I've got A and C. The angle between them is going to be beta. So my area here, 1/2 times one side times the other side times the sine of the angle between them. Fairly straightforward. To 2 decimal places, this is 8.19. It says this round this area to the nearest tenth. That's our 8.2. I am talking about area. I did have measurements on my sides of feet, so I need to make sure that my area has got the correct unit, square feet or feet squared.